Good morning and welcome to Algebra 1. Today what we're going to do is go over the first 2 pages of the quiz prep worksheet, and then we'll talk a little bit about yesterday's lesson where we used a piecewise function to find inputs and outputs. So, to begin, the worksheet on the board behind me, if you could make it out, gave you the first 2 problems were mappings. Now, the question was, is it a function, and if so, tell me why, if not, tell me why not. The first mapping is not a function because an input of 1 has 2 different outputs. With a mapping, we're looking for how many arrows come off each input. There should only be 1 to make it a function. The second mapping shows you over here the domain, and each value of the domain has only 1 arrow leaving it going to a value in the range. That mapping is a function. Again, every value, every input has only 1 output there. Moving down to the next 2. This table shows you that there are inputs of 0, 1, 2, and 2 again, which is a problem if the input is repeating itself, if it has a different output. Now, as you can see on your worksheet or possibly on the board, the outputs for 2 are -2 and also 3. That's a problem. That makes it not a function. It is not a function because the input of 2 has 2 different outputs. This graph over here, this loopy looking W, is it a function or is it not? The answer is it is a function because it passes the vertical line test. Any vertical line drawn anywhere on the graph will only intersect with the graph 1 time each time. So there's no possibility of a vertical line intersecting the red line of the graph more than once. This table over here shows you inputs of 10, 13, 8, and 9. Even without looking at the outputs, I can see it is a function because the inputs don't repeat, so they can't possibly repeat with different numbers. So it is a function. Every input has only 1 output. This graph here of the square, is it a function? No, it's definitely not a function. Every vertical line drawn anywhere on that graph intersects the graph at least twice, if not more, because the vertical lines that are the sides of the box are themselves breaking the rule of being functions because they are vertical lines. I can't show you any clearer than I have over here, so look at your worksheet for these 2. But the bottom list of coordinates, is it a function or is it not? Well, the inputs are 1, 2, 5, and 4. We already know, based upon the same rule that we use for the tables, it is a function because those outputs, those inputs rather, they don't repeat themselves. So because the inputs never repeat themselves, every input has a unique and distinct output. This list of coordinates over here is -1, 0, 0, and 3. Now the list included a repeating input. The input of 0 happened twice. But each time it occurred, it has the same output. It's 2 both times. That is a function. The next page, state the domain and the range. You don't want to list any value more than 1 time, and you also want to put them in order. So the domain are the x values, which are 0, 2, and 11. The range are the outputs, which is -1 and 3. That's how you'd write it. You can put commas in between those values. This mapping shows you the domain, which are these numbers, in order 8, 9, 10, and 13. The range are these numbers. -3 comes first numerically. So -3, -1, and then 5. When listing the domain for this scatter plot, you're going to list the x values of each one of those coordinates. So moving left to right, there's a dot where x is 1, 2, 3, 4, 5, and 6. The range are the y values of those coordinates going least to greatest, -1, 0, 1, 2, 3, and 6. I did that one. So for the list of coordinates, the domain, 10, 40, and 50. Don't list the 10 twice. For the range, 2, 3, and 7. Okay, now, For these problems, given the following functions, solve the problems. This is what we did the other day. When you're being given an input, you plug it in and solve. When you're being given an output, you make the function equal that number and solve. So let's do that together. So, f of -1. The f function is right here, 2x plus 1. So you're going to plug in -1 in place of the x. So it's 2, whoops, hint. So let's use the marker instead. So it's 2 times -1 plus 1. That's -2 plus 1, which is -1. And that's our answer. G of 8, use the g function, which is a half x minus 1. So it's half of 8 minus 1. Half of 8 is 4. And 4 minus 1 is 3. H of 3. The h function is -x minus 10. So it's -3 minus 10. -3 is, of course, -3. Minus 10 more is -13. G of 10. Back to the g function. 1/2 x minus 1. So it's 1/2 of 10 minus 1. Half of 10 is 5, and 5 minus 1 is 4. F of 7. Use the function for f of x, 2x plus 1. 2 times 7 plus 1. 2 times 7 is 14, and 14 plus 1 is 15. On the bottom row, you're being given the output, so you want to set the function equal to that number and solve. I hope I have enough room. F of x equals 11. So this function, 2x plus 1, has to equal 11. That's what it tells you to do. I don't have enough room to show every step, so I'm going to say what we would do. Subtract 1 from both sides. 2x equals 10. Divide both sides by 2. I'm going to move the camera back so you can see a little bit better. Okay, so divide both sides by 2, and x equals 5. For g of x equals 9, you take the g of x function, which is 1/2 x minus 1, and make it equal 9. Add 1 to both sides. 1/2 x equals 10. Clear the fraction by multiplying by the denominator. Multiply the whole thing by 2. And that gives you x equals 20. H of x equals 2. Well, that means -x minus 10 equals 2. Add 10 to both sides. -x equals 12. Divide both sides by -1. X equals -12. G of x equals 5. That means that 1/2 x minus 1 equals 5. Add 1 to both sides. 1/2 x equals 6. Clear the fraction by multiplying by the denominator, which is 2. X equals 12. F of x equals -3. So 2x plus 1 equals -3. Subtract 1 from both sides. 2x equals -4. Divide by 2. X equals -2. Okay. So those are all the answers for the problems that were on the homework for the first 2 pages. I only really intended for you to do the first 2 pages as homework, and the rest is for later. Right now, I just want to bounce back to what we were talking about yesterday, which is looking at a piecewise function and using it to determine inputs and outputs. So, let's take a look at, let me just exit this. If we take a look at one of our piecewise graphs, which, by the way, I did give you as a posting yesterday to the Google Classroom. I gave you this same form, which is just a bunch of piecewise functions. So we can take a look, and I'll move it in. let's take a look at this function right here. All I want you to do is look at it and understand what it is we're trying to do. What I'd like to do is be able to say the value of y if I know x, or x if I know y. So rather than write anything down, I'm just going to use it and point to it. Now listen, if I want to know what happens at, let's say, an x value of -4, I will ask you for f of -4. And then you'd say, well, gee, at -4 in the x, the graph is down here at -2 on the y. That's the answer. If I ask you for f of 0, that means when the input is 0, x is 0 right there in the middle. What is the output? Well, the y value is 1, so f of 0 equals 1. If I want to know what happens when x is 2, I could ask you for f of 2. Well, f of 2 means, look at where x is 2, and let's see what the output is. Looks like it's 4. F of 2 equals 4. That's how we're going to use the graph when I give you the input. Sometimes I can give you the output and ask you what input, what x, would get the output I'm looking at. So, rather than say f of 2, I might say f of x equals 2. That means, where is the output 2? Well, the answer is right here. Looks like about 1.5. Hard to be positive, because it isn't exactly on one of those crosses, but f of x equals 2 at about 1.5. What about f of x equals -1? What value of x has a y value of -1? Well, -1 for y is right here, and the value of x would be right there at -3, -1. So if I said f of x equals -1, you look for the -1 on the y-axis, and you find out where the graph hits right there. Looks like the x is -3. Make sense? Okay, so if you wanted to do more practice with this or move forward with this review, a good place to look is the next page in the packet, which is also your homework assignment. So what I'd like you to do is go to the next page in the packet and start doing that assignment. This is the homework assignment for the day. This page right here that starts with, how can you tell if a relation is a function from a graph, a mapping, coordinates, or table of values. If you look back to the beginning of this video, when we talked about the first page, you'll hear me tell you exactly how to find out if a graph is showing you a function from each of those. This question over here gives you a piecewise function, and it asks you to answer the questions about when g is 5, when g of x is 5, g of 5, g of -3, g of 1, g of 0, and then these two give you the outputs, g of x equals 2, g of x equals 8, which is essentially what we just talked about. So, that's the homework assignment. Please finish this. Please get it done. That way we'll know how prepared we are for what's going to be essentially a mid-unit test, a short test. Let me know if you have questions. Tune in to the Google Meet every day if you need to. And keep up. Hopefully everything's good. Tell me if it's not. Have a great day.